Yeah, hello, my name is Artem. I'm here with my colleague Joachim. We are working at CLYSO, helping people to run Ceph. And we want to present our case study of declarative object storage deployment using Ceph and Rook, and our attempt to deploy it in one click. So, yeah, the more about the project. So, the case study is based on a Pair project. It is an SAP project and funded by European Union in the scope of Digital Sovereignty Initiative. All work from this project is open sourced and will be donated to foundation. Our main goal in this project was to develop a blueprint for open cloud to enable governments and organizations to run their own cloud, to host their own data, and less rely on hyperscalers. So what do we mean by blueprint here? So it is like a distribution or collection of open source projects to host your own cloud. So all projects, all selected projects should be actively maintained. This means that if some project I need help with maintenance, with contribution, we help this project in the scope of a Pair. The blueprint should be seamlessly integrated, so all selected components should be tested in production with real application, work together smoothly, and it should be reproducible, so others could actually save time by using these blueprints. Deploy it with minimal human intervention, and for us, reproducible means that it has to be declarative. So that's why we selected to use Rook for this project. And of course, then this blueprint will be created. It should be also maintained. So we will have to check all the latest releases and versions of all selected components and continue to test it to be sure that everything still works. So this is some numbers from our case study. So we had a chance to have 100 Ceph deployments to actually test the reproducibility part. So the project started 6 months ago, and it's not finished yet. So we deployed 3 or even 4 clusters right now. So our first setup was not fully declarative. Some of things were still done using CLI tools and so on. But our latest cluster was actually deployed in fully declarative manner. And by the cluster, I mean Ceph cluster with the Rados gateway and object store. Yeah, and the size. So yeah, if we aim to replace, like, to be alternative for hyperscalers, we should also test for scale. So we should make sure that all selected components are scaled well, and our starting size of the cluster is 100 nodes and 1,000 OSDs. And the plan is to also scale this cluster until 2,000 or 4,000 OSDs. Yeah, so about the technology. So I told that the scope of the project is bigger than just object, so it's to provide cloud. And for cloud part, OpenStack was selected like as the most popular cloud software stack. And for us here today, relevant following projects from the OpenStack. It's a keystone for identity and access management. Swift is OpenStack. Object storage implementation and also interface. Barbican is responsible for key management. Cinder is block images for VMs, and the Manila is a shared file system. So yeah, it's quite common to use Ceph together with OpenStack to use it as a storage layer for everything. So normally you use Rados gateway or HW to replace Swift, Ceph RBD for block images, and also Ceph FS. So Ceph was selected like as the best open source storage for which scales really well, which mature and used by many companies in production already. So yeah, and of course, since we want to have a reproducibility and want to make it declarative, we also have Rook here. Rook is a Kubernetes operator for Ceph. So this means that you also have to use Kubernetes to run your Ceph cluster. So Ceph daemons run as a pods in Kubernetes cluster and orchestrated by Rook. So you have object storage custom resource to configure Rados gateway, and you also have a Ceph container storage interface to provision Ceph volumes to Kubernetes cluster. So yeah, so in this talk we will focus only on object storage for now. So so the idea was to replace Swift with Rados gateway and continue using like the same Keystone and Barbican installation with the same users without touching and breaking everything, and see how it works. So yeah, so we should have this in the end. So part one is about Ceph and OpenStack. So the most important thing you need to know here is that OpenStack Swift is eventually consistent storage, unlike Ceph. So Ceph and all its components, including object storage, block devices, are strictly consistent. So this means that in OpenStack Swift you don't have read after writes guarantee, but in Ceph you have. For us, it was actually a really good thing because if you expect people to move from AWS who are using S3 already, they expect object storage to be strictly consistent. So yeah, Keystone integration and Barbican and the Swift implementation exists in Ceph for a really long time, something like 10 years already. And S3 implementation in Ceph is really amazing. So when you move from AWS, let's say, to Ceph, you can expect that everything will work. So it's really feature-rich and stable. But we discovered a couple of issues with the applications which we were working with OpenStack Swift before. And we can say that Swift implementation is a bit less popular and so less mature today. Yeah, but anyway, for our new cluster, the customers were already using RGW Swift without any problems. But we had some problems to migrate like existing application, and I will explain exactly where. So you can download this presentation. I put links to all issues which you found. You can go through it later because some of them are really minor stuff, but I put everything just to use later. So I will highlight a couple of topics. So for example, public buckets or containers, Swift containers, were not working, at least with the Keystone integration, and the fix was done by community quite recently and was backported to Reef. Also, we noticed that we had application which was using ACLs, and when we started like RGW Swift with the same Keystone, we had a slightly different owner's ID in ACL. So it might be important for everyone, but yeah, it's broke one of the apps in tested environment. Yeah. Also, speaking about ACLs, so in Swift you can have role-based ACLs. So for example, you configure some custom role in the Keystone, and in Swift API you can tell like, okay, this role has read access to the bucket. So unfortunately, this thing will not work with RGW right now. Also, S3 conditional writes, it's quite a new feature introduced by AWS. So it's quite new and allow you to write on conditions, so if object already exists on or not exists. So it's also not supported right now by RGW, but I think it soon will be done. Yeah, so another topic which we discovered, so it's probably not very popular use case, but for example, OpenStack Swift also has some subset of S3 interface. And there is apps, at least in our environment, which are working with both. So for example, you write to Swift bucket and read from S3 and something like this. And you expect that they are pointing to the same storage, everything is the same, only interface is different. And it's also working with RGW. When you put objects into Swift, you can read it from S3, but not always. For example, if you enable server-side encryption in S3 and put some object, and you will try to read it with the Swift interface, you will get encrypted data, so it's not readable. And the same is true for versioning. So if you enable versioning with S3 in RGW, it won't be enabled automatically in the same Swift container. So the reason for that is that in RGW, Swift and S3 implementation not share the code too much, and they are a little bit different. And the goal of our project is actually to improve it and make Swift like in par with S3 and work together better. Also, we had a small problem related to quota and usage. So in RGW, you have pool placement and target placements. It's like equivalent of S3 storage classes. So for example, there is the idea that when you create a bucket or put objects in a bucket, you can tell S3 which storage you should use. Like this object goes to SSD, this one to SSD. And in RGW, you cannot track usage and quota per this storage class. You can only do it per user and per bucket. Yeah, so now, besides this, everything worked really well. So we already have fresh clusters with new applications who using it, and we have planned to like migrate the existing one. Now let's move to Rook. So I mentioned that from the start, we were not able to do configuration declaratively, but now it's possible. So how Ceph deployments with Rook looks like. So you have Kubernetes cluster with the nodes, with machines, which will be your Ceph nodes. You label this node with topology labels, like there they exist in your data center, like row, rack, blade, and so on. You declare device filters in Rook cluster configuration, because if you don't do this, Rook will try to discover all devices on the nodes and convert it in OSDs. If you don't want this happen, you can use filters. So then you start cluster. It's up and running. Monitors, OSDs, managers are here. Then you can also declare OSD pools with desired replications, and you can also declare your RGW instances using these pools. So in our case, everything in YAML for the latest cluster which we deployed, and what we had to fix to be there. So we added target placement support, because before it was not possible to configure this target placement, aka storage classes with Rook. We had to do this manually with the Ceph admin tool by editing zone and zone group JSON. There is also now support for multi-instance RGW deployment. So we're using it to have like separate configuration for RGW instance to serve Swift API, another one serving S3, and we also have admin ops instance which is not accessible outside for admin API. Yeah, and we also work in progress about allowing to combine internal and external resources. For example, having some monitor as arbiter outside of Kubernetes cluster. And we're also looking forward to observability improvements. There is a lot of going on in Ceph upstream already. So for example, if you upgrade to Squid, you will get a lot of new metrics for RGW, for example, latency per user and per bucket, and more. Yeah, so the scope of the project is a couple of years, so to finish it, blueprint to make it better. And our plan for this year is to maintain RGW Swift implementation, because we got the feedback from community that there are a lot of people are working on S3 and not many people are working on Swift, so we want to really help here and make it in par with S3 implementation. We want to start discussion with community about quota and usage management improvements to support target placement there. Now when we have cluster, we want to test day 2 operations with Rook and scalability, and also do improvements if we find that something could be improved. We also want to investigate like data migration topic. If you're coming from cloud into Ceph and you already have a lot of data, there should be a way to migrate your data, ideally without downtime. And yeah, the most important part why we are here to make this blueprint work, we want to build community around it, and we want to have other case studies. So if someone is interested to implement it in your company, probably today is too early because we need to finish it a bit and open source, and then we can connect and test it on different environments and make it better. Yeah, and if you're interested about this Apera project and initiative, there will be another talk tomorrow. It's about cloud-native APIs and integration across multiple providers for the same initiative, so you can also join. But yeah, I think I'm finished with the slides, and if you have questions, so we are happy to answer. Yeah, please.
So, thanks for the presentation and for the wonderful work. I'm not sure I've understood why we involved OpenStack with the Rook thing that is for Kubernetes. I mean, we could have done Ceph directly with Rook without involving Swift, or am I completely wrong?
Yeah, that's true, but... Oh, sorry, yeah. The question was, why do we have OpenStack at this slide? Because, yeah, if talk is about having reproducible Ceph deployment. So the scope of Apera project is to provide like the full cloud installation, including VM provisioning and all other stuff. And OpenStack was already selected to be part of this project. And if you're already using, for example, user management and encryption stuff from OpenStack, and it is supported by Ceph and should be integrated, yeah, we should use it together and integrate. And yeah, actually, I forgot to mention that Keystone integration was not supported by Rook until this summer, so if someone was missing it, please give Rook another try, so now you can also fully configure Keystone integration with Rook, yeah.
And one of the requirements was that it should be completely declarative and following the cloud-native way. So I think that was, and Ceph ADM at the moment is not supporting this, and that was one of the reasons why we have to choose Rook at this point.
Yeah.
So do you use any virtualization for your Kubernetes cluster, or do you directly install the kubelets on the bare metal machines?
Yeah, the question was, are you using virtualization technology to provide the machines for Kubernetes cluster? So yeah, it's on bare metal now. Yeah. But I think the plan was to also use KVM. Yeah, or no? Yeah.
I think for the Ceph nodes or Rook nodes, we have a separate Kubernetes cluster, and this is because of performance reasons, it's running on bare metal. If you want to run this in virtual machines, it's also possible, but at the larger scale, I think it makes no sense. If you have smaller clusters or you want to test it, I think feel free to test it. But from my experience, it's adding just another layer of complexity. So, and I could talk about this, I think, multiple hours, why I would not do it. So.
Thank you. Yep. Yeah, the question was, have I considered using Ceph ADM and make it work in a declarative way? Yeah, please.
I mean, at this point, Ceph ADM was in a major refactoring phase. It was also the idea to think about, okay, add this feature to Ceph ADM. When the project was started, was just the wrong timing for it. The other topic with Ceph ADM at the moment is how it's handling or upgrading the nodes as well, especially if you want to upgrade, and how it is checking the states of the whole cluster at each point. I think I was also not the biggest fan of Rook at the beginning. I mean, the first time I was in 2018 when I got in touch with the team. But I think that the higher potential, what you also can use from Kubernetes side, I think Rook is somehow, it started to convince me as well that Rook is perhaps, that we can use way more other features from Kubernetes and the other CNCF projects at the end. So, but we are, from our side, it's like this. We are just supporting both. So we are also using Ceph ADM. It's always a question back to the customer normally what kind of technology stack they want to prefer and what kind of team knowledge they also have. So
you can keep.
Okay, good. Okay.
So there was, yeah, please.
What kind of disk do we use for the cluster? At the moment, it's cost. So we have two pure NVMEs. That's the one setup, and the other one is mixed mode. So DB on wall on NVMEs with LVM partitions, and the data is stored on normal rotational disks, also with LVM partitions. Can you just repeat the question?
Do you have faced problems with latency on this disk?
So the question was if you have faced latency. I mean, we are doing this now, I think, since 12 years. So we know the caching topics of HDDs and so on. Yeah, we have seen this, but we directly gave the advice to disable caches on HDDs. So we have also a more intensive, also included in Rook, an intensive test upfront, so where we can identify all the devices and also make sure that a single device cannot slow down the whole cluster. So, yeah. So there's more upcoming. Observability is one of the big topics for this year as well. And also day 2, improving day 2 operations in general. And it's not only focusing only on Rook, it's also adding new features to Ceph and also bug fixing stuff. So, please.
Are you using Rook for multi-cluster things?
Okay, if you are using Rook for multi-cluster things, what kind of multi-cluster? Can you? Sorry?
Pool replication.
For pool replication? Not now at the moment. No. So just from my understanding, I mean, pool replication, we are talking about the object storage, so multi-site, or do we? Okay. I'm not a big fan of multi-site, so from an architecture point of view, I always try to have no strict dependencies across different zones or different clusters. We have experience in multi-site. We also did some deep dives over the past years, especially multi-site with in combination with features like versioning and others. Is always you always have to test everything up front if it's really working for each feature that you will use in the future, and it's a sticky relationship at the end. It also cannot answer your questions like recovery point objective, recovery time objective, and for this we had a talk I think 2 years ago with Chorus, so that's something else on top, another layer above, how we replicate data across the world or across data centers or availability zones.
Thank you.
Okay.
So do you see any benefits of using LVM for your OSDs? Because if I understand correctly, you use OSDs on LVM.
Okay, do we see any benefit of using LVM for the OSDs? I mean, as far as I can remember, if you use the RAW, then there was a problem that you sometimes get Atari devices detected. LVM, we use LVM for encryption because all the disks are fully encrypted. I think that's the major benefits. The other benefit, yeah. At the end, we try to use the most common setups that we see, and that's LVM with Ceph volume. Another thing is also that we are also fixing bugs sometimes in Ceph volume that I already thought that they are already fixed 10 years ago when we use Ceph deploy. Yeah?
Yeah, because the question was mostly because we tried to do Ceph on raw drives, and Rook, and it basically worked out,
Okay.
Out of the box.
Yeah.
And then we switched to LVM because that's more natural solution
Yeah.
that we can manage, and we had discoverability problems. So the OSD discover demon simply was not discovering the LVM drives. So
Yeah. Okay. We can talk about this later after this. Okay. But the general feedback on LVM and Rook and so on, yeah, I just wrote a long documentation how you can replace a single damaged disk without reinstalling the whole node. That's also an improvement that's perhaps Artem will implement. And I just provided the documentation from this. And that's exactly, they have to be careful in this area when you use LVM because it's really, it's different implemented if you provide a raw device or if you already provide an LVM device that's pre-configured. Okay. Hope that helps. So. Okay.
Okay.
Yeah. Thank you.